I hope you're excited to learn about Java and machine learning. And if there's any questions or anything you don't understand, like Ronaldo said, please ask away in chat, and I'll be happy to answer. And I'll go slow. Uh, I'll also do a quick poll because it's not a lot of us, so we can talk a bit informally. So yes, my name is Suyash, and I work at Oracle as a developer marketing director, and very excited to be virtually participating in the Latin America Oracle Groundbreakers tour. And I hope you all are having a good time, as there I saw the list of amazing talks. So I'm hoping you're learning a lot these days. Safe harbor statement. I have to put this legal slide. I think you've seen it probably a million times, so I will skip this. Who am I? This is the agenda. A little bit about myself, about yourself. Then we'll talk about why Java machine learning. I'll give you a little overview highlight of machine learning, deep learning. Then I'll show you some demos of machine learning in action using Java. And Q&A, typically, we would do it at the end, but feel free to put it in the chat. I try to take a look, but most likely I'll do it in the end. And then I have a course and a book around this topic coming up end of this year. And I have a newsletter for that. So I'll share with you at the end. If you'd like to sign up, you can get, I'll be posting chapters from the book in the newsletter to get feedback from audience. So we'll have a lot of interesting tutorials. So I told you about myself. I have been a Java developer for many years at Oracle. And 2 years ago, I transitioned about 2 years ago into developer relations, developer marketing, evangelism, all of that stuff. And and since then I've been also keeping an eye on machine learning in Java, which is a very exciting space. In my free time, I love to perform magic tricks. I have here a deck of cards and juggling, and we won't do that today. But if we were in person, I would be happy to show you something. How many people I would love to know are, let's do these two questions. You can type in the chat, just type 1, 2, or 3 for the first question. What do you want to learn in ML, deep learning, Java? Are you interested more in the data science or machine learning research type of problems and questions? Are you interested in more how to deploy Java AI systems? Or is just general interest in Java deep learning? Please type it in the chat, 1, 2, or 3. Type in the chat to all panelists and attendees so we can see some poll. I can get some sense. And then I have another question here. What is your current level of understanding in deep learning, machine learning, Java? Not at all, beginner, intermediate. Again, you can type in your answers, 1, 2, or 3. Okay, I see David. Thank you very much for those who are typing. 3 and 1. Okay, good. 1. Nice. Okay, I think I have an idea. This helps me, cater the presentation and also how I should go about showing you and explaining ideas and things. So here's the big picture. I'll go slow and I'll try to cover as much ground as possible. We only have 45 minutes, and I'll keep my talk focused around, this talk is more focused around, for this one, in second part, deploying machine learning versus doing hardcore machine learning research. And the target audience I have is number 2, beginner, but I will cover things slowly, and hopefully you'll be able to understand what we covered today, everything. Machine learning is very exciting, as you know, and the big picture is AI, right? And the type of machine learning today being used, the most popular one, is called deep learning. And deep learning is a special type of machine learning which is solving a lot of hard problems like text, right? Like I'm speaking right now, And if we were to, back in the day, we would have somebody listen to my speech, transcribe it, right? They would type text in English or Spanish, human. Now AI can do that. And how does it do it? By natural language processing. Or, you know, AI can detect my face, maybe my emotions, things like that through the camera, right? Or, data like COVID, right? The virus, what is the state of the virus? Or data around when you do credit card transaction. Have you noticed that you would get a message on your phone, SMS, or email instantly from your bank asking, hey, somebody tried to use your card? There's no human being involved in all of these problems nowadays. They are happening automatically. And how they are happening, a lot of these companies and these problems are being solved by using deep learning. And again, deep learning is a special type of machine learning. Machine learning is a big picture, deep learning is a small aspect. And it's exciting, but it also needs a lot of data. It's a data hungry problem. The more data you have, the better your AI model is, deep learning model is. The better your model is, the better your application logic or performance is, right? So, but the point I'm trying to make is that AI has been changing. It used to be rule-based AI, where you would write rule for everything. If this happened, do this, 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 this. And now, then it moved to machine learning, statistical machine learning. Now it moved to deep learning, more data heavy. Uh, and who knows what the future will be? Because the current deep learning also has very challenges, because only certain kind of organizations have large amount of data or capacity to train. Even if you use cloud computing, training from scratch can take hours or days, even weeks and months. Uh, Depends on how big your environment is, right? So the takeaway I'm trying to say is that as exciting it is, still today depends on your business problem. You can solve your problems by using old school AI, machine learning, not deep learning, or rule-based logic. Uh, so not everything has to be solved using deep learning. That's the main takeaway. Because I'm going to make this talk about deep learning, but I just want to remember that deep learning is like a hammer. It's like one powerful tool, but you don't need a hammer for everything, right? You only need for certain jobs. So here's a quick overview. If you have very large amount of data, you need high accuracy, and you have the time and capability to train extensively, then deep learning may be the right solution. Even if deep learning is the right solution, you can still try and use machine learning. Machine learning is, there are more simple models. They're not as big and complicated models like deep learning. They generally, you can train on the machine. They are very fast. They take less data to train. And sometimes their accuracy is not that great that maybe in deep learning. So there is a hybrid approach too. You can use some aspect of this technique, some aspect of this technique, mix it all up. Or, in AI term, they call it ensemble of different models, could be deep learning model, machine learning model, to solve a problem. So really something to think before you start to use these tools and technologies, because everything has a plus and a minus. There are these main categories of approaches to machine learning. So the most popular one is on the left, the supervised learning, where the model is is trained to detect, let's say, email spam or not spam, or fraud, like I said, credit card, or image diagnostic. Somebody like an expert, like a human being or doctor, would look at a lot of x-rays or MRI images and say, this one is this one has COVID and this one doesn't have COVID. They would label like maybe like thousands of those images, and there would be data set, and you would train AI using this supervised data set. So we call that approach supervised machine learning. And you can do various type of problems, like classification is one, where you classify or categorize. Is this X, is this Y, or Z? Different type of categories. And the machine, all it does, it learns from this data when it sees new data. So the old data, let's say the images for X-ray, you train it, and then you use the model and you show it something new type of image that it has not seen before, but it's the same type. It's also X-ray of, let's say, lungs. And the AI now, it has to tell, it gives you a prediction, a probability. So in machine learning, we don't have 100% right or wrong answers. The AI system gives us probability between, generally in systems you see between 0 and 1, and they give probability like 0.9 or 0.5, which would be 90% or 50%. And based on that, you can write your business logic, right? So I can write an application, business application, that if you upload your image of X-ray and machine learning model classifies it as positive with a 90% accuracy, then I can write my AI logic that, okay, this person, let's isolate them or something, right? So, but supervised learning takes human being who has to be an expert to create all this data, label the data, check, validate the data, all this thing. And it's time consuming, expensive approach. So AI researchers have come up with another way called unsupervised learning, where you don't have to provide a label data. Like every image, you don't have to label positive, COVID negative, and all this stuff. Machine learning model itself try to figure out from some amount of information that you give it. So their unsupervised is also fully unsupervised, or it could be semi-unsupervised. And then there is another type of machine learning called reinforcement learning, which is very popular in self-driving cars. So let's say like where AI system gets feedback from the environment. So or games. So like let's say a car is driving on the street and it's collecting all this data, and every time it drives, it's learning from the environment. Somebody comes in the road, it has to learn, okay, this is a person, maybe it'll stop. Next time it will see where the person is, it'll navigate around it. So the environment, when it teaches, when the environment is involved, when it teaches, then we call that we use technique like reinforcement learning for those type of problems. And then there are other type of problem like regression analysis, which is a very classical statistical problem, but we can do that using machine learning, or clustering. So clustering is, again, let's say COVID example. Let's say we have all the COVID data for all the Latin American countries, right? And now we want to find where are the hotspots, which cities are growing. So you would cluster in a map, and AI would detect the clusters, and it's very helpful for a lot of problems. So these are things we need to know so we can understand how we can use machine learning and AI in our jobs. Now, I'm going to focus on how I'm going to assume, like I said before, that we are not machine learning researchers. We're not building models from scratch, because these days, a lot of this research and models have been built already. And all you have to do is take existing model, you can train it, or they call it retraining. So you take the model, let's say it's built on, let's say maybe there's a model that exists on lung cancer data, and we want to use that model. So this model can see X-ray images and tell if this person has lung cancer or not. And now we want to, so it has been trained extensively, right? And we want to use this model for COVID data, which is a different kind of problem. It's not cancer, right? But it has similar images of the lungs. So similar features, but we want to detect something else. We want to detect presence of COVID or not. Are the lungs inflamed or not, right? So, so what you do is they call it retraining, or you use the existing model and you train generally the last layer, or you train a little, some portion of the model only, not the whole model. And then you don't need to spend so much time and effort and computing, because you're only training the last layer. Because most of it is similar, just something is different, some features that we are looking for, right? Like inflammation of the lung. And then you can use that new model in your own problem. So this is, I'm giving healthcare data because that's the thing around these days, but you can think of all kind of data, that is all kind of models. A lot of them I'll show you in a website where we can grab these models for text, images, all kind of problems, and then we can solve it for our use case. So how do you, when you have this model, how do you put that in your engineering system, right? Because that's the challenge. Because in software engineering, we already have these steps, right? The agile life cycle, where we develop, we test, we deploy. But in machine learning, is slightly different. So what we have here is the first step is the model building, right? And now, if you grab a model from the somewhere else, then you can, instead of building, think of model retraining. You are retraining existing model, and then what you do is model evaluation and experimentation, which in a sense is, in software engineering, it's like tests, right? You write code and you run some test on it, right? Integration test, regression test. So things like that you also want to do for your AI model. And once it's good, once it's, let's say, passing the test, or your bar, whatever your bar is, metrics are, you think it's good for production, then you put it in production. And how do we put it in production these days? As you know, I mean, everything is going on the cloud. uh, so you can of course do it on premise, but the more popular way and more efficient way is deploying these models on the cloud, and I'll talk in detail about that. And then once this model is there, now this is just the AI model, right? This is not the whole application. Now this model has to talk to your business application, right? Because model is doing the prediction, but your application may be doing many other things. So you have to connect it with that, and then you have to do the end-to-end testing, like a whole integration testing of everything. And then you deploy this final application, right, in whatever system, or you release your final big application that has the model and other logic. And then you monitor the performance. You monitor the application and you monitor the model, because what happens is these models are trained on a data that was in the past, right? And the model, as it is being used in the present, things change, the world changes, and new situations happen, and the model doesn't know the new data because it was trained in some data in the past. So it's very important in machine learning to do, they call monitoring or observability. You track the performance of the model. Is the model performance degrading? Like, is the prediction high, 90%, 95%? And the prediction, not only high, but is it accurate? Because model can be giving a right prediction but the wrong label, right? So there is a ways to monitor the performance of the model. And then what happens is, as you get new data, you can use that data to train the model further, right? And then you improve the performance. So there are approaches like these, and this whole field is now called machine learning engineering. And so one thing I'd like to tell in my talk is that this machine learning engineering is a field where, if you are a software engineer, your background is very important. Because let's say you're a Java engineer and your company decide to do some kind of AI investigation and use AI for some business problem. Now, somebody would do the data science research, but there has to be somebody who would know how to deploy these models into production. They need to know some machine learning knowledge, which I'm giving you today, and I'll give you resources where you can learn more. But you don't need to be a data scientist or AI expert. That's other people. And that's where the Java and the Python can come together. I feel like it doesn't have to be everything in Java and nothing in Python or something like that. I'll show you examples, like you can do everything in Java, but you can also work with TensorFlow in Python, where you can do the model training from scratch. And then you can deploy these models in production and use Java libraries to do what we call model inferencing. So let's go to the next slide. So I already talked about this. There are two types of basic category of roles. The first one, actually even three types. There is also a data, not a lot of companies have that role. Generally, data scientists are doing a lot of data engineering, but there are also people who are doing big data engineering, using Spark or Hadoop, those type of systems. And then there are data scientists who are consuming this data and who are looking at the new latest machine learning papers and the new algorithms, and they are crafting a model, right? And they're creating a special model for the business or organization. And then there are engineers who have some machine learning knowledge, how to take a model, how to infer the model, how to deploy it. And we calling themselves machine learning engineers or even machine learning ops. Like DevOps, there's an industry term now, new term you will see, it's called ML ops, where you're doing all of the cloud cloud operations, but for machine learning. So if you are a data scientist or more data engineer, like I asked in the poll, this is just something I want to share with you if you don't know, that Oracle has a lot of cloud services for data scientists and data engineers. And both, you can use notebooks, Python notebooks, or you can do everything in Java, like technologies like Spark and Hadoop, big data. Because in deep learning, data is the most important part. The data is the hardest, challenging, and it's the important part. The model is the most interesting part, but the most time spent is on the data problems, getting the right data, uh, cleaning the data, training using the data, a lot of the data stuff. So there are a lot of data services that we offer that you can use. Check it out. So now, I already told you, my goal is that hopefully if you're interested in this field, you can look into transitioning into machine learning engineering. And where your background as a Java engineer is very valuable, and you learn a little bit about machine learning. You don't become a data scientist unless you want to, but you can become enough machine learning expert that you know how to deploy these systems in high performance environments on the cloud. So I'm going to talk a little bit about cloud native, right? Because this is in today's enterprise. You may have already heard this in maybe other places. If you're a Java engineer, we used to write big monolithic applications, right? Like, Oracle, we have many products and many teams. And I used to work in one of those where we had this big WebLogic application. And I would work on certain part of it. If I'm doing UI, I'm only working on certain files. Somebody's doing the back end or authentication, other piece, right? And everybody's kind of scared to, sorry, there's a fire truck going here. So, and what happens in the big company, when you have monolithic apps, they don't know what some other files do. So people are scared to change something in some other file, right? And it's very brittle. So if you do something, one, you have to build the whole application from scratch. It takes time. You have code that you don't know, and you have to maintain that. Maybe it's dependent. So in cloud native technology, the one big problem it solves is that it breaks away this monolithic application into a microservices architecture, right? So and now this is what is happening, like including our company. We're going from monolithic and rewriting application to microservices that lives on the cloud. Because why? Because different teams can use different technology that's best for the job. So if you want to use Python for creating models, you can have your own repository and you can write that model, and then you can deploy that model, and I can have my Java EE application that consumes that model, right? And we can have a different team, and we can use something else for front end. We can use React versus using JSP or something like that, right? So it provides flexibility, it provides a lot of benefits, but the main takeaway is that in machine learning, you can have and all of these microservices are generally accessed over RESTful APIs, right? So on the right side, like I'm showing some endpoints, like this is your website, it would be /API/last name or department or title, things like that, right? And same thing, this is for getting information, right? Whatever, let's say you have a human resource application and you want to show data of all the employees and all of that, and you can access them over these REST endpoints. But you want to get, let's say, machine learning prediction of when we hire new people, how much salary should we give them for this person, right? Maybe let's say you build this type of AI system. Now your microservice, there would be one microservice that would do AI prediction for new employee salary, right? This background, this many years, and the model tells you how much it would be. So you would deploy that on an API endpoint, and then you would consume that API using your business application, right? Or it could be the client application that consumes that API and it does something. It shows, a graph or something, the numbers or something in the front end. So any question, just ask me, because in Java world, you probably already know there is a lot of machine learning, cloud native projects going on. There is one very popular called Helidon, which is open source, came out of Oracle. Another one called Micronaut, right? And if you live in the Spring world, there's Spring Boot, and there are many other Quarkus. There are many other frameworks where instead of writing big giant monolithic application, now you can write small, faster, lightweight cloud native application that live inside like these Docker containers and can be deployed onto things like Kubernetes, right? So so if you're using those things, it's very seamless to create a microservice that does machine learning part. And when you use cloud, you can not only create services. So here, for example, I have different machine learning services for different, let's say, part of the problem. Let's say if you are solving an image problem, you have a service that does image prediction. You have a service that does natural language processing on some text. Could be banking text, could be healthcare, any kind of text, right? There could also be a service which tells you model information. So it tells you, what is the performance of the model, the health of the model, all of these things. Um, or it could be model management, that you want to deploy, you want to try this model, the cutting edge model, or you want to do the one in production or development. So you can create services for different problems that you're trying to solve in this cloud native environment. And all of them could work inside a framework, like I mentioned before, cloud native frameworks. So, okay, so that's some of the big picture. Now let's dive deeper and we'll go into what are the machine learning Java frameworks out there. So there is TensorFlow for Java. Let me click and open this, show it to you. So a lot of people don't realize that TensorFlow, people think when somebody says TensorFlow, they think Python, right? But TensorFlow is actually a library that has many bindings. It is written in, I'll show you somewhere here, TensorFlow. It's not only written in, here you go. TensorFlow there's also TensorFlow JS, TensorFlow Lite, there is TensorFlow in Swift. TensorFlow is a framework, high performance framework, which is written in C++, and it has bindings or APIs for Java, Python, Swift, JavaScript, all these things. Python one is very popular because data scientists kind of like Python, right? Because they don't write full on, engineering code. They use these notebooks to do these experiments, which is fine. But when you deploy these applications, and Java is the #1 ecosystem for enterprise applications, right? There's Java and .NET, but Java is like the #1. Most of the big businesses run Java for their business applications. So TensorFlow supports Java, and currently this project is being worked in open source, and this is how you install it. So you install a Maven dependency, and this grabs the jar file that contains TensorFlow for Java classes, and then you use that, and I'll show you an example. And then this is what it looks like in a simple Maven project. And you have this class, let's say hello TensorFlow, and here, or let's just walk you through here. So here you import these classes. These are TensorFlow specific classes. Now, what I'm gonna first just go over a little bit of this code, then I'll explain you what these things are. So this is a very simple program. All it's doing is It's printing the version of TensorFlow library that's running. Not very interesting, but it shows you how to use TensorFlow in Java. So what is happening here is inside TensorFlow, or even, excuse me, even other libraries like PyTorch, everything in machine learning happens inside a graph, or they call it a computation graph. And in a graph, that's why we have this thing, we instantiate a graph here in this try block, and inside this try block, the other interesting thing is a session. So we create a graph instance and we create a session, because all the TensorFlow operations happen inside a session. And what we are doing here is inside the session, nothing interesting right now. We're grabbing a constant and printing it out, which is the value of the TensorFlow library. And we print that to the console. And you can run it just like a Maven application. So I'll show you a more interesting example. But I want to talk about these libraries. So there's also PyTorch. PyTorch is very popular library, came out of Facebook, and this is the PyTorch version of Java, right? So you can use PyTorch, and it's slightly different. I'll just go over the code a little bit with you. So here, if we see PyTorch, all these libraries, they have a slightly different way of doing the machine learning. So in PyTorch, they don't have this, they have a graph, but they don't call it a graph. They have something else. So here, you have this module where you load this model. So this model, so these libraries, what we are doing right now, we're using a pre-trained model, and they're doing machine learning inferencing. So, and then it doesn't do anything interesting. It just prints a tensor. Tensor is like an array like this, and it just prints that. So this is a simple example. That's one thing that's lacking, is documentation. These projects are really awesome, but they're lacking documentation and examples. They're open source, license friendly, that you can use. Researchers really love PyTorch, but the hard problem is solved. Somebody, Facebook actually, has built this library, PyTorch for Java. So you can have a PyTorch model that somebody trained in Python version of PyTorch, and you can deploy in Java application using this library. All it's missing is documentation. And that's something I'm motivated. That's where my book is coming. I'm writing a book which will cover a lot of these libraries with detailed examples, so that the knowledge is out there, and I'll have the code on GitHub. So these are two mature libraries. This is called Deep Java Learning. It came out of Amazon Labs. It's open source. It's a more mature library that that basically has, you can do. So this is one thing. These two libraries, they cannot do machine learning training. They cannot do deep learning training from scratch. Remember I said, like, data scientists do the training, so they don't provide that ability. What they provide is the second part, the inferencing. So you have a model, and you can run the model and get the prediction out of it in Java. These two libraries, they are full on. They provide not only training, inference, but everything else. DJLfor provides even more. It has support for ND arrays. It has support for Spark, a lot of these things, but it's also very big and bulky. So this library, you can read up on this. It's very interesting. They even have a model zoo. I'll walk over the code. This one, I'll do it in my demo. And just quickly, I'll show you this one also. This is also very good, popular, but it's slightly very bigger, bulkier. Deep Java Learning, it's now built, it's donated and part of, I think, the Eclipse Foundation, and it has a lot of examples in their GitHub repo for doing all kind of stuff. So let's just look at some things here. Let's look at this. So these are convolution neural network. These are more for image recognition. Maybe I think it's better to read the documentation. Yeah. So they have this image recognition. This is for classifying digits, MNIST. It's a very popular machine learning problem where you classify digits, right? Like 1, 2, 3, 4 type of numbers. CSV data, loading the data, because you need libraries to do all kind of stuff. low-level math operations, all kind of other things, advanced machine learning, doing classification on reviews like movies. And this thing uses something called word to vec. And this model does IMDb, which is a movies review site, right? Now you can use the same model and you can train it using this library for, let's say, instead of movie reviews, I'm interested in restaurant reviews, right? So I can use this model because it's been trained on similar data, but I can retrain it, the last layer, for my business. So it's a restaurant review, or doctors, medical, people review, great doctor. I can grab all the data, I can retrain it, and then I can use that. So, and it has a lot of other models and stuff, and you can read about it. So, So what the point here is, you can do everything you want to do in Python. You can do everything. These two libraries provide you everything. This two library provide you only inference right now. There's work happening very actively in this project. Some of my colleagues from Oracle are working on it, where it will be able to support also training, not only inference, but training, and for 2.0, which is the latest version of TensorFlow. So you're also welcome to contribute to these open source projects for Java. They're happening on GitHub and open source, and every help is welcome. So let's just do a time check. Okay, I think we don't have a lot of time. So I'm gonna quickly talk about the steps. So first, let's just do this over, this is more theory of machine learning. So what I'm talking about here is, this is what a graph looks like. I told you machine learning is a graph. Graph has these features. Now this is, more nitty gritty. We don't need to know, but it's good to know. So I showed something, and then it gives you output, which is a prediction. So let's say input could be many images, and output would be the image with the highest prediction. This is the car, and it can see many images, and model would do something. And and if it has many layers here, we call it hidden layers. Then it becomes a deep learning model. So so these are types of problems we talked about. It can do classification. Is it A or B, or is it clustering? It can look at data, and there is something called, when you train the model, you have to measure the cost, or they call it the loss function. So because you want more accurate the model to be, the smaller should be the cost. And this is a graph that's showing you how this algorithm works, called gradient descent, where the cost goes down. So here's the interesting thing. So in TensorFlow, we can train the model using this library called Keras and all that. And here, as you can see, in Java, what we can do is deployment. Training, they don't have Java right now, but they have for deployment. And training, they don't have JavaScript either. All these things are cutting edge. So once you have a model in this format called save model format, you can deploy in Java. So, and other exciting thing is that now you can deploy these models in a notebook. So there is a project called Jupyter Notebook. It's a website where you can run Java code on the web. And there is somebody made a Java kernel for that. So you can run Java code like you're seeing here. This is running on a website. And you can press, and you can run the code. So instead of doing it on your IDE, you can do it on Java, on the Jupyter Notebook. Okay, so let's do live demos quickly. I already told you TensorFlow. I'm going to show a more interesting one. This I have same, like the one we saw Google. It's very similar. I have this Maven POM XML file. And here I have, this is where I install, I have 1.15 version of a TensorFlow library. And the jar file it gets downloaded here. And it also, I'm grabbing a model from where? From cloud. So now when you have these models, you want to store them, you can store them locally, but if you want to deploy it in production, you want to have them in the cloud, right? And a good place to store models is called an object storage. And I'm storing it in the Oracle OCI object storage. And I grab this model, and what all it does image recognition. So like I was saying, so interesting thing happens is inside a TensorFlow graph. Um, so let's just run this code first. So this is the graph, and inside this graph, I have to pass some properties. So I'm gonna give it an image, and I'm gonna ask it to give me the label of the image. So I have to provide the images. These are the dimensions, and it has to be the same that the model can understand, because model is trained on certain dimension of images. So you have to provide that. And these are the operation that I'm doing inside the graph. Interesting thing happens inside this session. And inside this session, I run this session, and I pass this various parameters that you have to look at the TensorFlow APIs to understand what is happening here. And in the end, it gives us a prediction, which is a label. So I'm going to show you what I'm doing here. So I have these images. We have these images of these animals. This is a whale. This is a dog. It's called terrier. This is a porcupine, right? And now I'm using this model called Inception. And this model, I grab it from the cloud, this model, and this model is downloaded on my local machine. It's right here. It's called this .pb file. It's a binary file. It's a frozen saved model format from TensorFlow. And this is the labels. This is all the things the model understand. So what I'm going to do is I'm going to run this model and give it a new image. And in this case, I think I have an image of a whale. Yeah, and I'm going to pass that as an argument, and the model will give us a prediction. So let's run this. And I'm going to run this model right here. I have to provide it the class path and everything, because what I'm providing it is this is the main method, and I'm also providing as an argument the image whale.jpg, this one we saw. So I'm going to run this, and it should show us something here. So it's executing. This is the code that it's executing, and just in any time. And as you can see, it said killer whale match 41.59%. So it detected this as killer whale, which is true, but the prediction is very low, 41.59. Why? Because we don't have many data. So we want to train this model by giving it more images of this whale. This model probably was not trained on a lot of images of this type of whale. So the more images, more data it has, the better its prediction becomes. This is an example to show. Now I'm going to quickly, we are running out of time, so I'm going to quickly show you the different library and the different problem. This is the library. I have downloaded the code from DJLfor, the Deep Java Learning Library. And I have an example here. This is going to do another computer vision problem. And this is not TensorFlow. This is the one from Amazon Labs. It's called Deep Java Learning. And again, I import this using Maven. And here, Deep Java Learning, you provide all these dependencies, depending on all these libraries. And then we have this simple program called object detection. And object detection, all it will do is I have this images here. Wait a second. These images inside test folder. No, actually we provide dog, this one. And I'm gonna, and this first, in TensorFlow, the problem we did was label the image. Tell me what type of image is this. This program will do the bounding box. It will detect what are inside the image, and if it is anything the model knows about, it will create bounding box inside those. So whatever is trained on. So in this model, it's trained on dogs, pictures of bikes and all that. So it will, let's see. So I'm gonna quickly run this. So I've already compiled this code. We can just do it quickly one more time. Okay, and I'm going to execute this program. This is the main class also defined here. So it's going to run object detection. And in this class, we already provided the image of the test image that I showed you. And it will create image with a bounding box using this model. It's called a mobile net model it uses. And ResNet 50 is a type of architecture, the model. And we provided the criteria like the backbone, the filter, the operations, and then what we do is we create bounding boxes like these lines behind these models. So it looks like it's already done. So if it did, it should dump that file inside here, detected object, and here, as you can see, in this case, uh, it gives us prediction, very good prediction of these three, and it also creates the picture and it shows us these bounding boxes here for these three interesting objects. So that's it. I'm going to quickly jump to the talk. Sorry, we've gone a little bit over. Yeah, I showed you two demos of these two libraries. You can grab these. I have these on GitHub, and you can play with them, use it for your own, work. Um, there are other projects like this open source project called MLflow. It supports Java, and it does what we talked about very beginning: machine learning model tracking and model performance. So it's also very important for machine learning engineering. And then there is another technology called Onyx. What this does, so if these models can come from TensorFlow or PyTorch or DJL, and all these libraries have their own model format. So what this open source project Onyx has done is taken all these formats and you run this utility and it can convert one model format to the other. So I can run a PyTorch model in TensorFlow, or I can run TensorFlow in DJL using Onyx. So it's a very helpful utility. It also has Java APIs, and you can use this to grab any models online available. There are many models. There's also active work happening in Java ecosystem as part of JSR 389, where you can do visual recognition in Java without using these machine learning models, external, but standard API. So a lot of interesting stuff. Thank you very much. I hope you enjoyed it. I'm gonna just show one website and then I'm gonna take questions. This is, yeah.
Thank you, Suyash. Yeah, I mean, I was just checking the Q&A window, but
Yes. Let's do that. So, so this website I'm quickly going to show, because if you want to grab pre-trained models, you can Google TensorFlow pre-trained models, and these are a lot of models that have been trained on flower images and all these things, and you can download them. And like I showed you, you can deploy them right here. They're showing Python code, but you can run in all of these models, ResNet, and these are the files. And then these are the links go to the paper, so you can understand what this model is trained on, what kind of data, images, and all kind of stuff. And if you use Java library, then you can grab these models. You can pass the URL directly, and you can run these models within TensorFlow. And you have to know a little bit about TensorFlow for Java APIs. So the best place to do that is the Java docs. I couldn't go over everything, but it explains you, like we quickly covered, what is a graph, what does graph do, what are the methods of inside a graph, what is a session object, what does this do. These are very important things, because when you write this code, this is what you're writing. So let's take some questions now.
Yeah, I think.
Any question popping up?
Yeah, I think people commenting in the chat window, but saying thank you.
You can put it in the question or chat. I can happy to answer. But hopefully, yeah, you can see that there's no reason, if you're an experienced Java engineer, to forget everything because you can do all of these awesome stuff in Java. That's the main takeaway point. And you become more important, because a lot of these companies, they don't want to hire a new team in Python, people with and build a separate whole environment. If they can do everything in Java, and then you can show them how it's done.
There is one question. It says that can Python and Java
Coex GPU on the same installation. Interesting. I'm not understanding it, but I would say yes. The Python and Java, the best way to work it together is using microservices. So if you have on the same machine, of course, like on your local machine, you can install Java, you can install Python, you can install all of these, and you can run all these programs. But for these programs to talk to each other, there are a couple of ways. One is you create APIs, right? Like just like web APIs. So it'd be like localhost 8080 slash, API slash ML prediction. And the Java application would listen to that API and it would do something. So you can do it like that. And if you do it on the cloud, then you can use microservice architecture to put that on the cloud. Another technique is to do GraalVM, which is for if you want to build apps, or either cloud or native apps, like for local, you want to install and you want to use both Java and Python. You can check out GraalVM. It's another open source project, although its support for Python is limited right now. It has this feature of where you can write, where you can actually mix code. You can, in the same app, you can mix code, Java code, JavaScript, R, Python, and it has limited support right now for Python, because in Python, if you do machine learning, you need also the library. So it is very cutting edge stuff. Hope that answers your question. On the GPU, if you want to run GPU, all of these libraries are designed to run both on GPU or CPU.
Okay.
So, actually,
so I'm going to start sharing my screen, Suyash.
Yeah. Actually,
just to wrap up.
Yeah.
Thank you.
Thank you. And one thing, if I can put, I would like to put my, there is a book I'm writing, and there's a link to sign up if you would like. I'm just gonna quickly put it in the chat window. You can sign up in this bit.ly for receiving free chapters from my book. Thank you very much, Ronaldo. Sorry I took a long time.
No, thank you, Suyash, and try to use that link that Suyash shared with us.
And you can email me also, reach me out for any question. Happy to connect me LinkedIn.
So we really appreciate your support. This is the Groundbreakers Tour Latin America. We are very happy to have Suyash. I think this is the first time that he joined us in the tour. Hopefully next year, if we have an in-person event, he can join us as well. It was a very interesting conversation with him. The sessions are going to be recorded, so remember that you can play them if you want to retake the session. Those will be available in the next 2 weeks. All right. Gracias por su atención. Seguimos con la siguiente sesión que inicia en 5 minutos. Thank you, Suyash.
Thank you. Gracias.
Bye.